Surprise, I'm not here today. My basketball team has a game in Yuma, so we had to leave early, but I'm still going to teach you something. So today's lesson is on compound interest and continuous interest. These are the questions that are about like bank accounts and stuff. So we talked about like turning into millionaires and seeing your money grow. That's what this stuff is all about. But it's also used to model population growth, so animal and human populations, as well as bacterial growth. So when we do these notes, you're going to want to have your packets out and your notes. There's very little notes to take. I'm just going to show you a couple formulas that you have to know, and then you're going to have the packet out because we're going to go back and forth between the packet and then you practicing. So these are the two formulas that you have to know. One is compound interest. Compound interest means that you basically put in an amount and then it gets recalculated n number of times over a certain amount of time. The more you do it, the more your money grows. Continuous interest is the best type of interest because it is continuously growing no matter what, okay? So these formulas, they are pretty heavy in terms of having lots of letters. So I have some of these letters defined down at the bottom. So I will tell you some of the key things to note about these letters. So the first thing you need to know is the P. P happens in both of these formulas. So P is called the principal. Now the principal is a fancy bank way of talking about the starting amount. So if it says you put $8,000 into account, that means that your principal is $8,000. Now R is the interest rate. Now notice how it says rate, and we use the letter R for it. And it also has a star. The reason why it has a star is because rates are always done in percentages. And when we work with percentages, we have to convert them into decimals. Now, if you don't know how to convert a percent into a decimal, if it has a percent, that means that it has a decimal. So you have a decimal here. It could be 0.0. No one ever writes the 0.0, but it would be like 0.0. So let's say this is like 7.5%. If I want to convert this into a decimal, I would have to take the decimal and move it left 2 times. So this would convert and become 0.075. So that's what we would use for R in either of those formulas. Now, N is the number of times that your money compounds. That basically means that the principal and the entire formula is calculated, so you actually start with the higher principal the next time the calculation happens. N is going to be the number of times that that calculation occurs. There are some key terms that you will have to know for N. They could tell you that it's compounding yearly. So how many times would they calculate it? They would calculate it once a year. If they say biannually, that means they're going to calculate it twice in 1 year. If they do it quarterly, that means they're going to do it 4 times in 1 year. Monthly means 12 times in 1 year. Weekly means 52 times in 1 year. And then the mother of them all, daily, that's going to be 365 times in 1 year. Now, usually these are the ones that we see, but it could get even crazier and do like hourly and stuff like that, but that's too much and I'm not going to get into that. So in real life, these are the ones that you'll usually see. Now, if you have the option of selecting an account where you're going to put this money in, the more you go this way, the more times you compound it, the faster your money is going to grow, okay? The last thing is T. T usually represents the time, and time in these cases, a lot of times are in years. So you will have to know the difference between those two formulas, and I'll show you how to know the difference by using your packet. So if you look at your packet, this is problem number 1. It gives us a lot of information here, and we have to kind of sift through it. And to be honest with you, this entire assignment is a calculator assignment. So I'm going to show you how to like type stuff in and how to make tables and all that good stuff. So the first thing is that the principal is $2,500. That means they're putting $2,500 into an account. The rate is 8%, and they want to leave it in there for 10 years. Now, if you notice, it has the letter N. Anytime we have the letter N, that kind of tells us which formula we have to use. We have to use the compound interest formula. So N is going to remain a letter, and all of the other numbers are going to go into the calculator pretty much like so. So from here all the way to here, we're going to use this formula in order to calculate it. So P is the principal. So the principal is $2,500. Then we have a parentheses with a 1 plus the R is 8%. Now I'm going to use, I put a star on that last page where I had the R. The reason why it has a star on it is because you have to convert it. Most people mess this up because they forget to convert it. So converting is easy because you always just move the decimal 2 places, and if there isn't a number there, you just add a 0. So the decimal version of 8% would be 0.08, and the way decimals work is if you have zeros to the right, like this one here, you could just cross it off. So it's actually just 0.08. So we will use R equals 0.08 in our formula. And so that's going to be 0.08 at the top of that fraction right there. Clean up that 8. That's a weird looking 8. Let me fix that. 0.08. And then N is going to represent the number of times that it's calculated. Now, that's the thing we want to plug in each time. So our calculator doesn't have the letter N, so we're just going to type in an X right there. Close the parentheses. Now, these N's are exactly the same. So that means this one also has to be an X, and I want to multiply it by T, and it tells us right here that the T is 10 years. Now, I don't like putting X10, so I'm going to switch it the other way and write it as 10X. So at this point, once we get this exponent up here, we're ready for the calculator. Now, because this is formatted for a table, I might as well go into my table and type this stuff in. So let me delete all that. So we have 2,500, parentheses, 1 plus, and then we're going to hit the ABC button to make the fraction, 0.08. Then we're going to hit the arrow down to the bottom, and we're going to stick the X down there. Remember the X, the only X you're allowed to use is underneath the red alpha button. Then we're going to toggle to the right and use the close parentheses. Then we're going to use the caret key to get the exponent box, and then we're going to put in 10x up there. So 10 and then x. Now the nice thing about the table is mine is set to go from -10 to 10. But see, the thing is, like, not all the numbers from the table are in the chart. The good thing about this table is that you can easily override and overwrite the numbers. So if I need the number 1, I don't have to scroll down to 1. I can just literally go and type 1 and then hit execute. So that means that if I put in $2,500 at 8% for 10 years and they compound it one time, then that account is now going to have $5,397. And remember, this is money. So 0.3 is actually 30 cents. So this will be 0.30. So we started off with 2,500, and then we ended up after 10 years with $5,397, which is a pretty sick deal considering you don't have to do any work. All you got to do is put the money in there and let it work for you. Okay, so then we need the answer for 2, so I just go and plug in 2 and hit execute. So now my money has grown after 2 times compounded in 10 years. So they're calculating my amount 2 times in 1 year, or over the course of 10 years. So we've got 5,477, so 5,477, and then we had some change in that, so an 80 cents. So this would be 0.80. Then we can go and type in 4. So we hit execute. So now my money has grown to $5,520. And see, here's the cool thing about it. Every single one of these answers here is still 10 years. So you can see the more times that you compound it, it gives you a little bit more money each time. So if you had the option of going to a bank and finding out how many times they compound their interest, always go for the one that has the highest one. So this one is compounded 12 times a year for 10 years. So that's going to make that money grow to 5,549. And I think that was 10 cents. So 10 cents. And then the good one is going to be the 365. So you are literally recalculating your amount. Oops, not 360, 365. You are calculating the amount every single day for 10 straight years. So that makes your money grow to 5,563.30. So you can see when you do your comparison and you start off with 1 time compounding, it's 5397, and 365 times compounding, 5563, definitely higher. Now the best one of all is your continuous one. Now, but the thing about continuous though, is continuous has a completely different formula. So in the calculator, if we're going to put this into our calculator, we're going to have to make a couple of adjustments. So the principal is still the same 2,500 that you started with in the beginning. E is that number that we talked about in lesson 6B. R is 0.08, and T is the time. So we said up here earlier that the time is 10 years. So we have to multiply this by 10. Now, we don't need a table to just find out this one answer. So I'm going to go into my calculator, head over to the menu, and then get back into the regular calculator. And there's the answer. So if you type it into the calculator exactly how it looks, you end up with 5563.85. 5563.85. Now, I know some of you are looking, if you compare this one to this one, you're going to say, well, that's not that much. Yeah, but it is more. So the best one is the continuous one. Even though it's another, what, 55 cents, it's still more than before. And your end game here is to try to end up with as much money as you can. So with that being said, you should pause the video and you should be able to complete numbers 2, 3, and 4 in the packet. Okay, so number 5. Number 5 is kind of the same, but also a little bit different. It has a table format, but it has the keyword, and it says the keyword continuously. Anytime you see the keyword continuously, you're going to use A equals P e to the RT power. So we have to go through our problem and figure out what all of our variables represent. So it says complete the table to determine the balance A for $12,000 invested. If you are investing $12,000, that's what you're starting with, so that's your P. It says at a rate R for 10 years. Now up here at the top, it tells us what R is. R is 8%, but remember, R has to be converted first, so 8% would have to convert into, move the decimal left 2 times, so that would be 0.08 instead. And then your T is in the table, so that remains the letter, and so we'll actually use the letter X for this in the calculator. Now, because I want this table, and I don't want to have to keep going back and retyping this stuff, I'm just going to go into the table so that way I can manually override the numbers that are already in there. So we're starting with $12,000, so 12,000. And then we have E, shift LN. And then we have 8%, so 0.08. And T is changing every time, so I'm just going to put that as the X. So if I hit execute and get into my table, so let me go into my table. I want to type in 1. So after 1 year, my $12,000 has grown to $12,999. So I made $999 after 1 year, and I did nothing but put money away and not touch it. Then we're going to stick in 10 years. So in 10 years, my $12,000 is going to grow to $26,706. And I look at it in 20 years. So that same $12,000 is going to grow to $59,436. So the next one is 30. So I go ahead and stick in the 30. So my $12,000 after 30 years, which by the way is usually the average amount of years that someone works before they retire, you're going to have $132,287, $278. Sorry, I'm dyslexic. So 132 and then 278. And see, guys, the thing is, we're not doing anything different. All we're doing is letting our money work for us. And of course, this froze, so let me see if I can get this working. So let me go in like this. and I'll have to use the mouse. So this is going to be 2, 7, 8. Okay, so let me hit exit, and I'm going to go back, and I'm going to see what happens after 40 years. So 40 years grows to $294,390. So we got 2. So 294. This is going to be difficult. 294. I have to use the mouse because I think my pen died. And 390. 390. And then the last one, I'm probably not going to write it down. The last one, if I type in 50, that is going to be $655,177. So 655,177. So remember, guys, like we're only starting with 12 grand. We're not putting any more in. We're just putting it into the account and letting it sit. And you can see as your time increases, the money starts to grow significantly. And that's because of the shape of the graph. The graph starts off slow, and then it eventually curves, and towards the end, it almost shoots straight up. That's why it's so important to start young when you're investing. So with that, you should be able to do number 6. So you go ahead and pause the video and try number 6 real quick. Number 7. Number 7 says compounded monthly. So the big thing about the keywords here is it doesn't say continuously. So if it's not continuously, it's going to be this formula here with the 1 plus R over N and then N times T. So we got to figure out what all of our stuff is. First of all, the R is 6.5%, which means we have to convert it. So the decimal here would have to move 2 places to the left, ended up there. So it's 0.065. So we'll use 0.065 instead of the R. And this problem is actually still from the last group of questions. So you still have a principal of $12,000 and the time is the X value. So we're going to go ahead and start to plug this stuff in. So it's going to look like this. It's going to say A equals the $12,000 parentheses 1 plus 0.065, and then at the bottom. So here's the catch. This bottom uses one of those vocabulary words that I showed you, and it says monthly. So that means in 1 year, they're going to recalculate how much you have in the account 12 times. So N equals 12. That's your N value right there. N equals 12. So I'm going to put the 12 here, and if you notice the formula has the N in 2 places, so both of them are going to be 12s. And then T is the variable that's changing. So we're going to leave T, but we're going to put it as an X because our calculator will not understand a T. So we're going to put an X right here. So in the calculator, we're making a table. So I'm just going to go up here and adjust this. So I can go ahead and get rid of all of this stuff. Add the parentheses and put 1 plus ABC. The rate was 0.065. So that's 6.5%, 0.065 as a decimal. We're doing it monthly, so there's 12 months in a year, and the formula says to write the 12 twice. Make sure you put it up as the exponent though, so 12, and then we're going to stick the X so that way we can have the calculator plug in the different X values. So I'm not going to write this, my pen died, so you're just going to have to get it off the calculator, so get ready to hit your pause button. So after 1 year, your money is going to grow to $12,803. After 10 years, your money is going to grow to $22,946. After 20 years, your money is going to grow to $43,877. After 30 years, which is a typical age for the amount of time that you have to work to retire, $83,901. 40 years, if you decide to keep working, that account is going to have $160,435. And then if you're crazy and you work for 50 straight years, your account is going to have $306,781. Again, guys, the key is the money grows. The longer you put it in, the money grows faster. So with that, you should be able to do number 8. Okay, so now number 9. So number 9, this is just a question that involves bacterial growth, and it's still going to use the same formulas we've been talking about. Bacteria and population, a lot of them use this continuous growth. You can tell it's continuous because it has the E in it. T is the time in hours, so it says use a graphing utility to graph the model. So what we're going to do is we're actually going to use Desmos, because doing it on a graphing calculator is kind of a pain, because you will have to play with the viewing window in order to see it. So I forgot what the problem was. It was 100. So we got 100 E, and you literally just type the E in, to the 0.2197. And Desmos doesn't understand any letters other than X, so I'm going to put the letter X right there. Now, I'm going to hit enter so you can see the graph, and you can't see the graph. Well, here's what you should know. We already learned that there's going to be an asymptote at 0 because the K value is 0. We cannot see it, okay? Even if that was empty, it's still at 0, which means that we should have a growth function, which means the left side should be flat and the right side should shoot straight up after some point. But the reason why we can't see it is because of this number right here. This is the A value. The A value is in front of your base. The base is E, and that's also your y-intercept. So if you zoom out on Desmos, you will be able to zoom out. Oops, I didn't want to push home. You will be able to zoom out and see that in fact it does cross at 0, 100. It flattens out over here on the left side because we already know the basic shape of all of these things, especially a growth function, is flat, and then it curves up once you get further to the end. So this says use a graphing utility to graph the model. This is not a hard model to graph. So I would start off flat. I would go like this and hit right here. And then I would show everyone that that right there is 100. And not to mention, I would also probably add the asymptote. Remember, again, your asymptote is because the K value right here is 0. Part B says use the graphing utility to approximate P of 0, P of 5, and P of 10. So what they're asking you is how much bacteria is there at time 0, at 5 years, and at 10 years. I think it was in years. Oh, it's in hours. Okay, so this bacteria is growing very quickly because it's growing in hours. Now you can go to the graphing calculator and use that, but I got Desmos open and it's already kind of done. So I just have to go in here, take out the X, and put in the numbers they told me. So if I plug in 0, the answer is 100. So it says use the graphing utility to approximate P of 0. P, oops, I don't want that color. P of 0 is going to be 100. And then P of 5. So now I just have to go to Desmos and plug in the 5. Oops, that's not Desmos. Desmos is over here. So I can go up to the 0, delete that, and put in a 5. The answer is 299.966. So this one is 299.966. And then finally, the last one is P of 10. So how much bacteria will there be after 10 hours? So we go into Desmos. That's not Desmos again. Go into Desmos, go up to that 5 and change it to a 10. 899, 798. So 899 and then 798. This part right here says verify your answers part B algebraically. So what they want you to do is they want you to use the formula. The formula and a regular calculator. And I'm not going to really show you how to type it in. I'll just show you what you need to plug in. So when it says P of 5, you're going to put in 100 E to the 0.2197. And then right here, this is where it's at. This is where you're going to add the 0 to get the answer. So that answer was 100. Then you're going to redo the problem, but up here you're going to put in 5, and that's going to give you 299.966. And then you're going to redo the problem again, but then up here you're going to put in your 10. And so that's going to give you your 899.798. So the purpose of that question right there, algebraically, is just to type it into the regular calculator. Now, with that, there's one more question, so you can pause the video or stop the video and do number 10. I will say that number 10 has a part G to it, And I'm not going to talk about it in this video because it's pretty thought-provoking, and I want you guys to think about it. So I'm going to end this video here. Enjoy the weekend. Finish off the assignment. This one is going to be due on Tuesday, and I will see you when I get back on Monday. Peace. Oh my God, that sounds like Miss Patton.